Hey Zach, great question here. Let's take a few minutes. I think if we pull a few, or just make up a few examples, we can see what's happening. So if n is even, what's basically going to happen to all this if we're taking the index and the exponent are the same deal? Okay, so let's consider the square root. I'll just write this in of some number squared. Okay, well what's going to happen there is we get a, right? The 2 and the exponent, they all cancel out and we just get a. Okay. What would happen though if we took the square root of negative a squared? Something like that. We're squaring the radicand, the number underneath that square root sign. Well, what's going to happen again, I'll write the 2 even though we never do. We know that's going to cancel, but we have to evaluate what's underneath here first. So negative a times negative a is just going to equal a squared, right? So the square root of a squared still equals a. So we could say, in general, that if the index is positive, so if n or the index is positive, or sorry, if it's even, then we're going to get a positive answer. All right, so if n is even, we get a positive answer. And this will apply even if we did like the fourth root of some negative radicand to the power of 4. Well, again, remember that's going to equal, if we just evaluate in there, negative a, negative a, negative a, negative a. And as we multiply these, that's going to become positive, right? That's going to be positive a squared. That's going to be a squared. So we're still going to get positive a to the 4. And the fourth root of something to the 4 cancels, and we just get a positive answer. So in general, if the index n is even, we get a positive answer. Okay? Now let's consider what's going on with an odd deal, an odd number. So let's take the cubed root of a cubed. All right, now here, all this goes away. We know that, right? That just equals a. So, all right, that's kind of neat. But what happens if we're taking a negative something like that, a cubed? You could throw that in brackets if you want to get fancy. I'm not. Well, again, we have to evaluate what's going on under here. So that's negative a times negative a times negative a. Now, as I multiply this through left to right, this is going to be a squared times negative a. So that's going to get us our negative a cubed. It's still going to be negative. We'll never lose the negative when we have an odd number. Okay? It'll always be negative if we're starting with a negative radicand, the number underneath the square root symbol. So if we take the cubed root of that, of negative a cubed, that goes away, but we're still left with this negative a. All right? So again, in general, when we're talking about a negative radicand, if n is odd, we get a negative answer. Okay, so that's kind of how you can think about this. And if you ever get a situation where they're throwing numbers or letters at you like that, right? Just replace it with an even and an odd number. Make this a 2. Make that a 2. And figure out what's happening. Oh, okay, it all goes away, I get a. If we're talking about an odd number, make it a 3. Make this a 3. Okay, so that's kind of what's going on there. Hopefully that'll give you some insights to that question, buddy.